What is a blockchain? A blockchain is a distributed database or ledger shared among a computer network's nodes. They are best known for their crucial role in cryptocurrency systems for maintaining a secure and decentralized record of transactions, but they are not limited to cryptocurrency uses. Blockchains can be used to make data in any industry immutable, the term used to describe the inability to be altered. Because there is no way to change a block, the only trust needed is at the point where a user or a program enters data. This aspect reduces the need for trusted third parties, which are usually auditors or other humans that add costs and make mistakes. Since Bitcoin's introduction in 2009, blockchain uses have exploded via the creation of various cryptocurrencies, decentralized finance, DeFi, applications, non-fungible tokens, NFTs, and smart contracts. Key takeaways. Blockchain is a type of shared database that differs from a typical database in the way it stores information. Blockchains store data in blocks linked together via cryptography. Different types of information can be stored on a blockchain, but the most common use for transactions has been as a ledger. In Bitcoin's case, blockchain is decentralized so that no single person or group has control. Instead, all users collectively retain control. Decentralized blockchains are immutable, which means that the data entered is irreversible. For Bitcoin, transactions are permanently recorded and viewable to anyone. How does a blockchain work? You might be familiar with spreadsheets or databases. A blockchain is somewhat similar because it is a database where information is entered and stored. But the key difference between a traditional database or spreadsheet and a blockchain is how the data is structured and accessed. A blockchain consists of programs called scripts that conduct the tasks you usually would in a database, entering and accessing information and saving and storing it somewhere. A blockchain is distributed, which means multiple copies are saved on many machines, and they must all match for it to be valid. The blockchain collects transaction information and enters it into a block, like a cell in a spreadsheet containing information. Once it is full, the information is run through an encryption algorithm, which creates a hexadecimal number called the hash. The hash is then entered into the following block header and encrypted with the other information in the block. This creates a series of blocks that are chained together. Transaction process. Transactions follow a specific process, depending on the blockchain they are taking place on. For example, on Bitcoin's blockchain, if you initiate a transaction using your cryptocurrency wallet, the application that provides an interface for the blockchain, it starts a sequence of events. In Bitcoin, your transaction is sent to a memory pool where it is stored and queued until a miner or validator picks it up. Once it is entered into a block and the block fills up with transactions, it is closed and encrypted using an encryption algorithm. Then, the mining begins. Blockchain. The entire network works simultaneously, trying to solve the hash. Each one generates a random hash except for the nonce, short for number used once. Every miner starts with a nonce of 0, which is appended to their randomly generated hash. If that number isn't equal to or less than the target hash, a value of 1 is added to the nonce, and a new block hash is generated. This continues until a miner generates a valid hash, winning the race and receiving the reward. Generating random hashes until a specific value is found is the proof of work you hear so much about. It proves the miner did the work. The amount of work it takes to validate the hash is why the Bitcoin network consumes so much computational power and energy. Once a block is closed, a transaction is complete. However, the block is not considered to be confirmed until 5 other blocks have been validated. Confirmation takes the network about 1 hour to complete because it averages just under 10 minutes per block. The first block with your transaction and 5 following blocks multiplied by 10 equals about 60 minutes. Not all blockchains follow this process. For instance, the Ethereum network randomly chooses one validator from all users with Ether staked to validate blocks, which are then confirmed by the network. This is much faster and less energy-intensive than Bitcoin's process. Blockchain decentralization. A blockchain allows the data in a database to be spread out among several network nodes, computers, or devices running software for the blockchain at various locations. This not only creates redundancy, but maintains the fidelity of the data. For example, if someone tries to alter a record at one instance of the database, the other nodes would prevent it from happening. This way, no single node within the network can alter information held within it. Because of this distribution and the encrypted proof that work was done, the information and history, like the transactions in cryptocurrency, are irreversible. Such a record could be a list of transactions, such as with a cryptocurrency, but it also is possible for a blockchain to hold a variety of other information like legal contracts, state identifications, or a company's inventory.